Okay, so we said that the magic number in chemistry is 8. So that all elements in a chemical reaction are trying to get to this magic number of 8. Now they can do it either by giving away electrons, or they can do it by taking electrons. So let's take a look at the periodic table here. And so in columns 1 and 2 and 3, so in all three of those columns, it's going to be easier for the atom to give away its electrons. So it's going to give away its outer electrons, so then it thinks that it's in column number 8. For columns 5, 6, and 7, then for them, it's easier to take an electron in order to get to their magic number of 8. Well, what about the ones that are in 4? Well, they actually can go either way. So it's just as easy for them to take electrons as it is for them to give electrons. And then what about the ones in column number 8? They're perfectly happy the way that they are. So they are completely unreactive in chemical reactions. And what did we call the ones that were in column number 8? Those were the noble gases. Okay, the closer you get to the edges of the periodic table without getting to the number 8, the more reactive the chemical is going to be. So that anything in column 1 is highly reactive because it only has to give away one electron. The ones in column 2 are also pretty reactive, but not as reactive as column number 1. Column 7, very, very reactive because all it's got to do is take one electron. Column 6, pretty reactive, but not as reactive as column 7 because column 6 would need to take 2 electrons to get to column number 8. So these would make for good essay questions on the exam, being able to explain the reactivity. And so we explained the reactivity of sodium, and then we explained the reactivity of chlorine, and then we noticed that when you put the two of them together, an electron is transferred from one atom to the other, and then that made table salt. Okay, then you should know the names of the 3 different ways that atoms hook together to make a molecule. And so we've just mentioned ionic bonding. An ionic bond makes ions. Electrons are physically transferred from one element to another, and then that ionizes it. So it now has a net charge. And then the other one, because it gets the electron, is also charged, and then opposites attract. Okay, then we talked about covalent bonds where the electrons were shared. So for purposes of the exam, make sure you understand sodium chloride and also be able to explain water, H2O, and how the electrons are shared in water, but they're given away and taken in sodium chloride. And then you also have metallic bonds where you have the sharing, so it's kind of like the covalent bond, but instead of sharing just 1 or 2 electrons, you're sharing trillions and trillions of electrons. Okay, then we have bonds that hold molecules together. And so I said that there was only 2 of these that you needed to know. So understand why water is polar and how the polarability of water allows it to stick to itself to make liquid water. And then the other one was how can water pull away the chlorines and the sodiums from salt and cause the salt to dissolve. So those were 2 kinds of bonding that a molecule could have with another molecule. Do not worry about the two examples that are over there on the left-hand side, the one that's on the top and then the one that's on the bottom. Okay, and then who cares? So now that we know that molecules can bond to molecules, what are some examples of this? So the first one was surface tension, where the water molecules are bonded so tightly to each other that it makes a film that some kind of little insect can crawl on top of. Okay, then viscosity. So viscosity means that these molecules are, the more that they bond to each other, the more viscous that liquid is going to be. So water is not so viscous. Maple syrup or oil, on the other hand, is very viscous. And then you had capillary action, where one molecule bonds to a different molecule. So let's say that this is paper, and then you put some ink on the paper, then you put it into some alcohol. The alcohol starts to stick to the paper because it's a different substance, and as it crawls up the piece of paper, it's going to carry some of the ink with it. And so this is called capillary action. So just be able to describe to me what is surface tension, what is viscosity, and what is capillary action. So that takes care of our lesson on atoms. So now in our next lesson, we're going to review electrostatics.